which is the inverse of f of x equals 1.5 raised to x plus 4. So by vocabulary, the function here is an exponential function because the exponent is a variable, it's x. And by definition, the inverse function of an exponential function is always a logarithmic function, leaving the first option to be a distractor. So it's not an answer. So it's between these three functions here. So what should we do in order to find the inverse? So we will follow the basic steps. So we will change f of x to y, 1.5 raised to x plus 4. Okay, and then afterwards, we need to flip x and y. So x equals 1.5 raised to y plus 4. Then, of course, we will isolate y. Remember, we can always express logarithm to exponential and exponential to logarithm based from our lessons from the previous. So we will isolate y. Since 4 is added, we do everything in reverse. We will subtract by 4, leaving x minus 4 equals 1.5 raised to y. Now, since this is an exponential function, to change this into logarithm, so our subscript, our superscript is y. This is your logarithm. So therefore, this will be y. If we change it into logarithmic form, so our answer is y, which is the exponent. Remember, in logarithm, the answer is always the exponent. And the exponent here is y. So therefore, our answer is y. Logarithm, and our base is 1.5 because that's the base for y. And our power is x minus 4. Okay? And based from the change of base, since as you can see, the problem is asking us to change base. There is no base for 1.5. And in the change of base formula, we can express this as a quotient of the power and the base using the same base. And in this situation, in our options, all of them are common logarithm, meaning to say the base is 10. So we can say that the logarithm of x minus 4 is divided by the logarithm of 1.5. Both of them have the same base. So therefore, our answer is letter C. Inverse of a logarithmic function, so it should be an exponential function because the inverse of a logarithmic function is an exponential function, which means that we will have to take out the option C and D because they are not possible answer to the problem, since the inverse of a logarithm is exponential is between A and B. So what should we do? So the first thing we do is we change f to y. So f of x to y. So y equals the logarithm of 2x minus 1 base 5. Then of course, after that, we need to switch our x and y. So x becomes y becomes x. So x equals log of 2x minus 1 base 5. Okay? And because the inverse of a logarithm of exponential, we can express this into exponential function. So we just have to know, by the way, that's why, we just have to know that our base is 5 and our exponent is x. So this is our exponent, this is our base. So therefore, the exponential form of this is 5 raised to x. Okay? Base raised to the exponent is equal to 2y minus 1. And so therefore, we just need to isolate y, and we just have to do everything in reverse. So minus 1 is adding 1 on both sides of the equation, and that's 5 raised to x plus 1 is equal to 2y. Multiplying by 2 is dividing by 2. So we will divide the whole function by 2. So y is equal to 5 raised to x plus 1 all over 2, or we can change this into the f of x form, or f of inverse x form, is equal to 5 raised to x plus 1 all over 2. And in our case, our answer is letter B.